Good morning, everyone. I'm delighted to be here. Last year, during the global journey of the GM global manufacturing events around the world, we were delightful to have the GMIS event in our headquarters nearby Paris, where we really showcase great things. So coming back a year later and showing you progress is an interesting move. I would like to talk to you about a few things today. The impact of the new economy on the manufacturing itself, the impact of the new economy on the workforce of the future, on the impact of this new economy on the transition to value chain. I don't think we are anymore in a product economy. We call it the experience economy. The product is not the value. The value is coming from the experience it does provide. At Dassault Systèmes, we serve 250,000 of the best enterprise in the world. So we provide the virtual platform to imagine, simulate, and produce. I'm used to say that the world flies with our software because most, if not all, of the planes today that flies are designed and simulated and produced with our software. Same with the automotive sector like Toyota, Volkswagen, and many other big groups, but it's expanding in life science. So I would like to address the topic of virtual universes used not only for goods, but used for life science. That's why you have the sphere here, modeling human skeleton, human cells, being able to do for the FDA the simulation of the Living Heart program, which is now recommended as the simulation platform for all research in medical science. And of course, the geological aspect of it. Why so? Because if we want to be living in a sustainable world, we have to change the relationship between product, nature, and life. And the beauty of the digital world, it can change the frontiers. We started 35 years ago by demonstrating to the world that yes, the experimentation in the virtual world was a prerequisite, a foundation of the transformation of global collaboration to create new type of solutions. The very first large-scale program that happened in the world was the Boeing 777. It was the first ever digital airplane created without physical prototyping. 3 million parts doing the full assembly, and the airplane was introduced to the market in '94. It has changed the world of aerospace, but it has also changed the world of industry at large. And now, of course, with the new way of producing, of having modular, extremely modular production centers, it's going to change again. The world is under overcapacity today. However, the solutions which are offered are not satisfactory because it has to be more sustainable. So our bet is that doing more of the same product will not make it. Our vision of the future is to think and imagine differently. It's not more of the same thing. It's about creating a universe where you can integrate all effects, the holistic approach between life, nature, and products. And I will illustrate to you in a moment why this is happening. All the new EV companies in the Silicon Valley in the last 18 months have selected Dassault Systèmes platform. Why so? Because you don't do an electrical vehicle the same way you do a basic old nature vehicle. It's connected, it provides an experience. It's not about the same packaging. It's not at all about the same experience to the consumer. And that's the very, very heart of why the power of imagination is going to change the new world of manufacturing. We are involved in 50 global programs for the new world of manufacturing. We are in 1,000 virtual workshops hosted by the MIT around the world, what we call the Fab Labs, demonstrating with young generation how the future will be done. And they are not using at all the existing traditional industry methods. They are using the virtual world to create things which at the beginning do not work, and finally will work by integrating software everywhere. Many programs here to be noticed, of course, in China with Digital Manufacturing 2025, Creative Industry in France or Korea, on Industry 4.0 in Germany, for example, or America with the what we call Manufacturing Renaissance initiatives. Those programs, they are very different, but they have something in common. What they have in common is the bet that we have to invent new solutions for the economy. And that's the fundamental aspect of it. Well, if you look at the constraint in cities, was last week in Beijing, we signed an agreement for a digital platform for innovation in sea, air, and space, where in the center of Beijing, we will be creating a virtual platform to connect education research centers sponsored by MIT to really showcase how this new world is going to work. But of course, it's the same for energy. We are, of course, very involved in nuclear programs, wind programs, sun programs, as well as personalized health, because personalized health is going to change the medicine. Because personalized health will provide completely different nature of equipment for healthcare, and of course, on the education side. So here are a few examples. The last 3 Nobel Prizes in physics and chemistry are using Dassault System scientific platform. Why so? Because at the heart of everything is not software, it's science. We can simulate cholesterol propagation in human cells. We can create materials with material science from the atoms, as opposed to take basic materials which have always been used on the same one in the industry. The material science, the life science are going to change the entire manufacturing world. We created a few months ago the first 3D printed building with ABB robots, was presented to the world. You can imagine that cement that was used was not regular product. It has been engineered to provide this kind of services. And of course, if you think about education, we touch 10 million students per year. Students are not interested to use software. They are interested to use content, to get experience, to understand how things work. So the content and the experience are very critical for students. Otherwise, they quickly lose interest. They want to know how it works, they want to see the simulation, and they want to discover new phenomena and reproduce them themselves. So the workforce of the future and the relationship we have established here with universities is based on the fact that the student can discover how it was before and how it can be tomorrow. The power of those universe, life, product, and nature coming together are a fundamental element of a new balance for a more sustainable set of innovation. And that's what we have created here with many, many new startups that we have sponsored to print our gains, to be able to use that in life science, like what you see here. Those startups got the funding, and it's about new materials. It's about things that have never been used before. So both food and personalized health are going to converge to create a new environment in this context. Last year, in an event in Boston called Science in the Age of Experience, many scientists from the life science world recognize, as well as FDA specialists, that modeling and simulation are changing the way personalized science is going to work. So when it comes to holistic approach to innovation, we think that if 50% of the population are in cities, it is, if we think that we are in an experience economy, we better have to understand not only where people are living, but the context in which the products humankind creates are going to be used. So it's upside down. It's not anymore more of the past. It's about defining the end experience to confront all talents, to invent new solutions that will provide the right social contribution, the right business contribution for people in different countries. In this example, the Dassault system platform that was used for the Boeing 777 25 years ago and now used by most of the most innovative automotive companies are being used for the entire virtualization of Singapore. Why so? How can you organize the best flow for transportation? How can you manage safety without simulation? How can you do simulation in high risky situation in case of serious problem? How can you position buildings in a city where you will enable the city to auto-clean itself? In a moment here in these videos, you are going to see how, by having this full experimentation, you can evaluate not only how transport or waste management or noise in a city are happening, but you can improve the city in a global evaluation standpoint. The noise evolution here was fully evaluated. This is the win to get a better environment for cities. Most of the buildings those days are not positioned rightfully because people don't do simulation on modeling. And here is an example of how those experiences can completely change this new type of services within cities. To conclude, of course, you can imagine that in the autonomous transportation, whether it's electrical buses in cities, the full understanding of the experience, the journey on the modeling and simulation is changing completely, even the bus characteristics. With our friends from Volvo Commercial, we demonstrated that we could move buses with half the weight of existing battery simply by managing the experience on the power supply through the journey. Here is with kids in Singapore. We tried them for a month, and we demonstrated to the government the mass transportation was not suitable for students. And this was done using modeling, simulation, big data analytics at the speed of a click, because we just had to collect the data and create this environment. If 50% of the population are in cities, the entire portfolio for products which are used by people in their social environment, as well as people in their business environment, are going to change. And of course, as will the intercity transport. We are now building microfabs with Boston Consulting Group, where we demonstrate that by using those microfabs, we can train new workforces in a few hours to assemble electrical scooters. And we are building those centers with Boston Consulting around the world to demonstrate to the world that the future of manufacturing is about the future of knowledgeable workforces. It's about the quality and the capacity to train people. It's not going to come from more automation, because we are already in overcapacity for existing product family. So that's what I wanted to share with you as a perspective. The manufacturing by itself is not going to be guided by the digital world. It's the other way around. The new imagination will drive new type of capacity to produce what is needed for the society. Thank you very much.
Well, that was fascinating, but I have an overriding question for you. What does this do for perhaps to stimulate a new generation of engineers and people to work in manufacturing? Because you know, it's long been, or has been seen as an industry, a business that young people don't want to go into, but presented with virtual reality software like this and quite astonishing systems. What does that do?
We have very interesting experiences that we did across the world, and I will give you a few examples. Many of you have understood the phenomenon of Fab Labs.
Yeah.
The phenomenon of Fab Labs is a beautiful phenomenon because it's about new generation of people who wants to imagine and do. So the Fab Labs is the rendezvous point where they say, I'm going to meet someone, I'm going to be able to do it. 3D print, laser cutting, whatever, to create things. So the Fab Lab event, I think it's a beautiful showcase, and we have 1,000 of those with MIT around the world where Dassault System is providing software, is an outstanding demonstration that new generation of people wants actually to do things in manufacturing. The second evaluation we did, we went to poor area of the world. We went to Rwanda, and we provided, under the sponsorship of the Rwanda government, a virtual environment to change the training program. Today, it's very, very hard to learn. When we collectively learn, we take books, we listen to the professor, we have to transfer what we read to our mindset to imagine. Imagine a world with augmented reality, virtual reality, where kids can discover phenomenon, chemistry, life science, human cells, just looking at how it's working. And then they click to understand what is the science inside, but only after. So even education now is upside down from that standpoint. So those experiences have created an amazing new social dynamic for people who did not like school, did not want to go and sit, you know, and read documents. They said, because they want to touch and they want to do things. And you know, the beauty of the AR, VR is that it's going to transform in a fundamental way the way we train people, the way we educate, the way we discover. If I show you today the propagation in a VR environment about how the cancer is propagating in a human cell, now we cannot stop it yet, unfortunately, but we are showing that, and we are showing that it's actually a valid simulation. I think you create ambition for people who were not necessarily interested to do and to learn.
That's fascinating. Thank you very much indeed, ladies and gentlemen.
Thank you.